Hello everybody, this is the notes for Advanced Geometry section 7.5. All right, so far in this chapter we've been talking about all kinds of different stuff relating to right triangles. So the next step is a thing called trigonometry. Basically what trigonometric ratio, that terminology, and the whole idea of trigonometry, it is the relationship between an angle measurement in a right triangle and a ratio of side lengths. So there's a bunch of different trigonometric functions that relate this angle measurement to a ratio of side lengths, but that's really what it is. It's just an answer, it's a ratio of two side lengths in a right triangle. So what I mean by this, and actually let me go back here. This is an important statement here. For a given angle in a right triangle, the ratio of two sides will always be the same. All right, key idea. Sorry. So for a given angle in a right triangle, the ratio of two sides will always be the same. So I have this right triangle here. All right. This is angle B right here. It's a 90-degree angle. Whenever I move this around, it's staying 90 degrees. So we got a right triangle. I'm going to concentrate on this angle A right here. It is stuck at 50 degrees. It doesn't matter how big or how small this triangle is. This angle is 50 degrees. So for a given angle measurement, we're talking about angle A, the ratio of two sides will always be the same. Now I'm just going to compare side BC and side AB. All right, that's this ratio. The measure of side BC divided by the measure of side AB. So for that given angle measurement A, the 50 degrees, in this right triangle, as I move this triangle around, watch that ratio. You can see the side lengths are changing, but that ratio between those two sides has not changed one bit. That's the idea of trigonometry. It really doesn't matter what the side lengths are. If you're dealing with a right triangle and you have a certain angle measurement, the ratio of the sides in that right triangle will always be the same for that angle measurement. Okay, that's the whole key idea of trigonometry. So we got three sides in a right triangle. I'm looking right down here. We got the three sides. We really have 6 different ratios. Now, technically, there's only 3 of them, but if you flip them over, you got 2 for each ratio. We're just going to compare, for this section, we're just going to talk about one of those. It's called the tangent ratio. Okay, so the key thing again is you got to be dealing with a right triangle. Now, the tangent ratio, it is looking at the ratio of the two legs, just like I did in that picture where I was moving the things around. So, looking at this picture up here, you got the hypotenuse. Okay, that is always a fixed side, meaning it's always across from the right angle. So, the tangent ratio, you take the tangent of an angle measurement. So, we're going to take the tangent of angle A. Now, the tangent ratio is a specific ratio. It compares the leg of the opposite side divided by the leg which is adjacent to that angle. So if we're looking at angle A here, across from it is the opposite leg. Right next to it is the adjacent leg. So this tangent ratio is always the same ratio. It's the opposite side. Tangent of an angle is always the opposite leg divided by the adjacent leg. Always. As long as you got a right triangle, it's always that ratio of those two sides. So as you can see in this picture, it would be the length of BC divided by the length of AC. Now, if we go to angle B, well, that changes some things around now. So if we're looking at angle B, black that out here. If we concentrate on angle B, this becomes the opposite side, opposite leg, and this becomes the adjacent. So the tangent of angle B would be the length of AC, the opposite side, divided by the length of BC, the adjacent side to that angle. But you notice it's always the same ratio. It's always, tangent ratio is always opposite divided by the adjacent. Okay, and then we're talking about the legs. So, how the trig functions work. All right, there's just a couple of just fundamentals about them. You always take the trig function of an angle, all right, meaning it's tangent of A, tangent of angle B. When you take the tangent of an angle measurement, the answer is a ratio of two sides of that right triangle. So the tangent ratio, again, it's specific. It's opposite over adjacent. All right, so if we take the tangent of angle A, looking at this picture, angle A is right here. The tangent ratio is always opposite over adjacent. So if we look at angle A, 5 is the opposite side, 9 is the adjacent side. Here's our right angle. This is the hypotenuse. We're not mentioning the hypotenuse with the tangent ratio. It's the opposite leg divided by the adjacent leg. So for this triangle, the tangent of angle A would be 5 over 9. All right? For the tangent of angle B, now we're looking up here at angle B. Now these sides switch. 9 becomes the opposite side, and 5 becomes the adjacent side. So this tangent ratio for angle B would be 9 over 5. But it's still that same ratio, opposite over adjacent. It's just now we're changing our reference angle. All right, so we'll do a couple more examples of this, but this is the idea. You take the trig function of an angle measurement to equal a ratio of two sides. So in the case of the the tangent function, again, it's the opposite leg divided by the adjacent leg. As you're working with trig functions, down here, a couple of comments. Nothing goes into or comes out of a trig function. What that means is you don't mess with this angle A or this angle B. And when we do a couple examples in the next video, we'll have the tangent of 50 degrees. You're not going to touch that 50 degrees. It stays there. It's inside the trig function. There is a big wall blocking off all of that stuff. You take the tangent of 42.5 degrees. Nothing touches that angle. That tangent of 42.5, that's nothing deals with that. All right. The other big thing is make sure your calculator is in degree mode. For those of you with an 83 or 84 of your own, or if you're using one of the school's calculator when you're in class, to know which mode it is in, hit the mode button and you scroll down to that third row. It says radian and degree. You want to be in degrees. You have to be in degrees because we're going to be dealing with degrees. All right. If you have if you're one of the people that uses their phone for a calculator, this is just an image of the iPhone calculator or the iPod calculator. You'll notice right up here, it says DEG. All right. If it doesn't say that, then you need to be hitting this button down here where it says rad, where the arrow is. That'll change it to radians. I think once it's in radians, this button will say degrees. But it needs to be in degree mode. No, I don't want to save that. What in the world is all this? Whatever it is, I don't want it. Let's go back here. Okay, so you got to make sure your calculator's in degree mode. Every time you turn your calculator on, make sure it's in degree mode. Otherwise, you're going to get a wrong answer. So we'll do these examples real quick, and then there's some other examples that add a little bit of work to this. So for this first one, number 1, it says find the tangent of A. Okay, so the tangent of angle A equals the ratio of the opposite leg. So in case of angle A, the opposite is 45 divided by the adjacent leg, which is 28. That's your answer. Okay. Some of the problems ask you to round the decimal to round the answer to 4 decimal places. Just do 45 divided by 28 and go to 4 decimal places. Also wants the tangent of angle B. So again, tangent ratio, opposite leg divided by adjacent leg. So for B, 28 becomes the opposite, 45 is the adjacent leg. So there's your answer to tangent of B. It's that ratio of two sides. In the second example, the tangent of angle A. Opposite side is 56, adjacent side is 33. For the tangent of angle B, opposite side is now 33, the adjacent side is 56. Okay, and that's all you got to do for these things. All right, that's it for this video. The second video, we'll be talking about actually solving some side lengths using this tangent ratio. Please watch.